You think dark matter is something NASA found and then locked in a filing cabinet. That's the assumption hiding in the title, that there's a thing, a particle, a substance, a cosmic shadow, sitting somewhere behind a classified stamp, and if only they'd tell you, the mystery would collapse. No, that's not how this works. That's not how the universe works. Dark matter didn't enter physics like a discovery. It entered like a crime scene. Gravity showed up to do a job it didn't have the resources for, and the numbers refused to cooperate. That's it. No reveal, no object, just a ledger that wouldn't balance. You were told the universe is mostly empty space sprinkled with stars and galaxies. That sounds right. It isn't, because when astronomers actually measured how galaxies move, measured, not imagined, the math said something else was there. Not glowing, not shining, not interacting with light at all, but pulling hard. Here's where your intuition betrays you. You think seeing is believing. Physics doesn't care. Gravity doesn't ask permission from your eyeballs. It acts relentlessly, whether the source glows or not. And when galaxies spin faster than their visible mass allows, you don't get to vote on the outcome. The universe has already decided. So physicists did the only honest thing available. They admitted something was missing. Not something mysterious, not something secret, something required. Dark matter isn't a claim. It's an accounting fix, a placeholder name for whatever makes gravity behave the way it demonstrably does. That's why asking what is dark matter already smuggles in a false assumption that it's a substance waiting to be photographed. You're picturing fog, or particles, or invisible rocks drifting through space. That's your sci-fi brain talking. NASA never promised you an object. NASA promised you measurements. And those measurements say the universe contains more gravitational influence than atoms can provide. End of story. Notice what didn't happen here. No one woke up wanting to invent dark matter. It's deeply inconvenient. It complicates equations. It humiliates intuition. If galaxies behaved the way you expected them to, dark matter would never have been proposed. But they don't. Galaxies rotate like records that refuse to slow at the edges. According to everything you think you know about mass, the outer stars should peel away. They don't. They stay locked in, moving as if held by an unseen hand. You can dislike that fact. You can distrust it. The stars remain unimpressed. So what did NASA do? They checked again and again. Different telescopes, different wavelengths, different teams, different decades, same result. That's the part people skip. There was no single dramatic moment, no press conference where someone said, "We found it." There was only a growing pile of observations all pointing in the same uncomfortable direction. Visible matter is not running the show. He doesn't. Gravity already works, painfully well, predictably well. Dark matter exists because gravity is behaving exactly as measured. The anomaly isn't gravity failing. The anomaly is matter failing to show up where gravity says it must be. That distinction matters. Because the moment you treat dark matter like a mysterious dew, you stop asking the right questions. You start waiting for an image, a detection, a reveal. And you miss the real shock. The universe builds structure using ingredients you don't understand, and it doesn't slow down to help you catch up. And no, NASA is not hiding a solution. If anything, they're advertising the problem loudly. Entire missions are designed to map gravitational distortions, light bending around nothing visible, space warped by mass that refuses to announce itself. That's not secrecy. That's confession. Another assumption collapses here. You think dark matter is rare, exotic, an edge case. It's the opposite. Ordinary matter, the stuff you're made of, the atoms you trust, is the minority component of the cosmos, a rounding error with delusions of importance. Galaxies don't form without dark matter scaffolding. Clusters don't hold together. The large-scale universe doesn't look the way it does. Atoms didn't build the cosmic architecture. They moved into it later. Let that land. Everything you think of as real, stars, planets, chemistry, biology, rides on top of something we don't understand and can't directly detect. That's not a NASA failure. That's a reality failure. And this is where the title misleads you in a subtle way. What NASA isn't telling you suggests intention, withholding, strategy. as if knowledge exists somewhere offstage. The truth is colder. NASA is telling you exactly what they have: motion curves, lensing maps, background radiation patterns, simulations that only work if unseen mass exists. What they don't have is a story that fits your intuition. And that absence feels like secrecy because humans confuse explanation with comfort. You don't actually want data. You want a picture you can imagine. The universe does not provide those on demand. Here's the deeper problem, and this is where things start to get uncomfortable. Once you accept dark matter as an inference rather than an object, a new question replaces the old one. Not what is it, but why does the universe require something we can't see to behave correctly? That's not a particle question. That's a structural one. Because every time NASA points a telescope at the cosmos, the same message returns. Reality is consistent, repeatable, and indifferent to whether you find it intuitive. Dark matter is not an embarrassment waiting to be resolved. It's a reminder that understanding lags behind measurement, and measurement always wins. So if you came here expecting a reveal, some suppressed truth, some missing document, you're already misaligned with how science operates. The real mystery isn't hidden, it's openly unsatisfying. You live in a universe where most of the mass doesn't glow, doesn't touch light, and doesn't care that your brain evolved to understand rocks and fire. And yet, it dictates the motion of galaxies and the shape of space-time itself. If that feels unsettling, good. That's accuracy. Because once you stop treating dark matter like a secret and start treating it like a demand the universe makes of your theories, a much larger problem comes into focus. One that doesn't stop at galaxies. It moves outward and backward, toward the structure of space-time itself. You still think this problem lives out there, in galaxies, in clusters, and deep space where nothing you do matters. That's another comforting illusion. Because the moment you follow the logic instead of the imagery, dark matter stops being a cosmic curiosity and starts attacking your sense of scale. Let's collapse a habit you didn't know you had. You assume gravity is simple. Heavy things pull. Light things don't. Distance weakens the effect. End of story. That works on Earth because Earth is forgiving. The universe is not. Once you leave the planetary scale, gravity stops behaving like a force and starts behaving like geometry. Mass doesn't just pull. It reshapes space-time. Paths bend. Clocks drift. Light curves. None of that asks whether you're comfortable with it. Now add dark matter to that picture. You're no longer dealing with invisible stuff floating around. You're dealing with invisible influence rewriting the geometry of the universe. The scaffolding that determines where galaxies form, how fast they grow, and how matter flows across billions of years. And here's where intuition really starts to fail. You think time is universal. You think space is fixed. You think motion is absolute. That sounds right. It isn't. NASA's measurements already forced physics to abandon those ideas a century ago. Dark matter just finishes the job. Because once most of the mass in the universe is invisible, every assumption you make based on appearance collapses. Take time. You experience it as a steady march, seconds stacking neatly. But clocks don't agree with each other once gravity enters the equation. Put one clock deeper in a gravitational well, and it runs slower. Not symbolically, not metaphorically. Actually, that's not philosophy. That's engineering. Satellites fail if you ignore it. Now imagine a universe where most of the gravitational wells aren't made of visible matter. Time itself is being subtly sculpted by something you cannot see. That doesn't make time mysterious. It makes your expectations naive. Or take motion. You think you know what at rest means. You're sitting still right now, as far as your body is concerned. But zoom out and you're moving with Earth, around the sun, through the galaxy, pulled along filaments shaped by dark matter distributions laid down billions of years ago. You're not drifting randomly, you're following curvature. And that curvature wasn't created by stars. Stars arrived late. This is why the human brain struggles here. You evolved to throw rocks accurately, not to intuit space-time shaped by invisible mass across cosmic time. So you keep trying to localize the problem. Find the particle, isolate the thing, point to it and say there. Physics doesn't cooperate. NASA maps dark matter not by seeing it, but by watching how it distorts everything else. Light from distant galaxies bends as it passes through regions with no visible mass. Background radiation carries faint imprints of density variations seeded before atoms even existed. That last part should bother you. Dark matter doesn't just affect galaxies today. It affected the universe before stars, before planets, before chemistry. It shaped where matter would eventually condense. It pre-wrote the cosmic map and let normal matter fill in the lines, which means the question, what is dark matter, might be backward. The more dangerous question is, what does it mean that the universe organizes itself around something fundamentally inaccessible to our senses? Because once you accept that, another assumption falls apart. You think understanding requires visualization, that if you can't picture it, you don't really know it. Physicists abandoned that requirement long ago. Equations outperformed imagination, and measurement became the final authority. Dark matter lives comfortably in that regime. It is known by its consequences, not its appearance, just like space-time curvature, just like time dilation, just like quantum fields you've never seen but depend on for every solid surface you touch. This isn't a failure of science. It's a failure of common sense. And common sense keeps trying to sneak back in. It whispers that maybe gravity itself is wrong. Maybe the equations need tweaking. Maybe there is no dark matter at all. That idea has been tested repeatedly. Modified gravity models can mimic some observations, but they break others, especially when you scale up. The universe is consistent in a way bad ideas aren't. That's how they get eliminated. What remains is uncomfortable but robust. Something non-luminous dominates cosmic structure, interacts primarily through gravity, and refuses to behave like anything in your daily experience. So let's push the scale one step further. If dark matter shapes galaxies, and galaxies shape clusters, and clusters trace vast filaments across the observable universe, then you are living inside a structure you cannot see, built by rules you didn't evolve to intuit. Your sense of here and now is provincial. This is why dark matter isn't just a missing ingredient. It's a warning label. It tells you that the universe operates on principles that do not scale down gracefully to human intuition. What feels obvious locally becomes misleading globally, and we haven't even touched the extreme environments yet. Because once you combine invisible mass with extreme gravity, regions where space-time is stretched to its limits, the notion of understanding itself starts to wobble. Not because physics fails, but because the questions you want answered stop being the right ones. The universe doesn't care whether you can picture it. It only cares whether your models survive contact with data. And the data is about to get far less forgiving. By now, you should feel the floor starting to tilt. Good. Because the universe doesn't ease you into its extremes, it drops you in and waits to see which ideas survive. Let's go where intuition finally gives up pretending. Black holes. You think you know what they are? Collapsed stars, bottomless pits, cosmic vacuum cleaners. That sounds right. It isn't. A black hole isn't a thing in space. It's a region where space-time has been bent so violently that the future points inward, not pulled, directed. Once you cross that boundary, every possible path forward leads deeper in. That's geometry, not drama. Now add dark matter to this picture. Not as fuel, not as prey, as context. Most of the gravitational environment in which black holes form is already dominated by mass you cannot see. The visible star that collapses is the tip of the iceberg. The space-time it warps is pre-shaped by invisible structure long before collapse begins. So when you imagine black holes as isolated monsters, you're missing the setup. They are actors on a stage built mostly from unseen mass. And here's where your intuition commits a fatal error. You assume understanding means reducing things to parts. Identify the ingredients. Name them. Control the narrative. That works in kitchens. It fails in cosmology. Dark matter doesn't announce itself in laboratories the way atoms do. Decades of experiments have looked for interactions beyond gravity. So far, nothing decisive. No sparks, no tracks, no satisfying reveal. Just silence. And gravity continuing to behave impeccably. Which leads to an uncomfortable pivot. What if the universe isn't obligated to present its foundations in forms you can directly interrogate? Early universe cosmology makes this unavoidable. When scientists reconstruct conditions moments after the Big Bang, they aren't guessing. They're matching patterns in the cosmic background, temperature fluctuations, density variations, large-scale structure, and every successful model includes dark matter from the beginning, not as decoration, as necessity. Without it, the universe stays too smooth, too boring. Structure doesn't form fast enough. Galaxies don't emerge in time. Reality misses its own deadlines. So dark matter isn't a late addition to fix a problem. It's baked into the opening act. Which means this mystery isn't about what we haven't detected yet. It's about the limits of how detection works. You were raised to trust contact, touch, light, interaction. But gravity doesn't care about any of that. It is the most democratic force in physics. It couples to everything with energy and momentum, including things that refuse every other interaction. Dark matter exploits that loophole perfectly. Now zoom out further. The observable universe is threaded with vast filaments, cosmic highways of matter stretching across hundreds of millions of light years. Galaxies cling to these structures like dew on spider webs. Those webs are traced not by stars, but by mass, mostly dark mass. This is the point where understanding has to be redefined, because if you insist on comprehension meaning I can picture it clearly, you lose, permanently. The universe does not negotiate with your cognitive preferences. Physics has already moved on. Understanding now means coherence across scales. It means models that survive collisions with data from telescopes, satellites, and simulations. It means accepting entities defined by influence rather than appearance. And yes, this is where people start whispering about secrets, about what NASA won't tell you. But notice the pattern. And what NASA does this without me, every time physics reaches an edge and a fact, it seems to be a good piece of symptom. It's that answers are missing. And that distinction matters. NASA publishes the measurements, the maps, the anomalies, the failures. What it doesn't publish is a bedtime story that resolves your discomfort, because there isn't one. Dark matter sits at the intersection of extreme gravity, early universe physics, and the limits of detection. It refuses to collapse into a neat explanation because reality rarely does at its foundations. This isn't ignorance disguised as mystery. It's knowledge pushing against the boundary of what questions even make sense. And here's the pressure point. If most of the universe's mass is invisible, and if space-time itself responds to that mass, then what you see is no longer a reliable guide to what is. The cosmos becomes a place where effects outrun appearances, and causes hide behind consequences. That's not a bug. It's the operating system. Which brings us to the final reframing you probably weren't expecting. The deepest problem dark matter exposes isn't that something is missing. It's that you are not the reference scale. Your intuitions were tuned for survival, not truth, for mid-sized objects moving slowly in weak gravitational fields. The universe, meanwhile, operates across extremes of mass, energy, and curvature that flatten those intuitions without apology. Once you accept that, the frustration shifts. Dark matter stops being a secret you're denied and becomes a reminder reality does not prioritize being understandable to you. And the further you push toward singularities, toward the first moments of time, toward the full architecture of space-time, the clearer that becomes. The final collapse isn't of a theory. It's of the assumption that understanding must feel satisfying. Here's the final assumption you haven't noticed yet. You think the universe is something you observe from the outside. You look up. You point telescopes outward. You talk about deep space as if you're not already submerged in it. That separation feels natural. It's also false. Dark matter ends that illusion cleanly, because it doesn't just shape galaxies. It shapes the environment that makes your existence possible, not poetically, structurally. Without it, matter doesn't clump fast enough. Stars don't ignite on schedule. Heavy elements don't form in time. Chemistry doesn't get its chance. There is no version of you in a universe without dark matter. That's not comfort. That's bookkeeping. And yet, you cannot see it, cannot touch it, cannot directly interact with it. The dominant mass of reality passes through your body every moment without noticing you exist. Sit with that. You are built from a minority ingredient, living inside a framework controlled by something fundamentally alien to your senses. And you still wake up assuming the world is made mostly of things like you. That assumption collapses here. This is why dark matter isn't just another unsolved problem. It's a boundary marker. It tells you where human intuition stops being a useful guide. Past this point, only measurement counts, only consistency, only what survives contact with reality. And this is where people usually want reassurance. They want to hear that science will figure it out soon, that the mystery will resolve into particles or fields or something comfortably nameable. Maybe it will, maybe it won't. The universe has no obligation to converge on explanations that feel narratively complete. Physics doesn't reward patience or hope. It rewards models that work. Right now, the model that works says this: most of the universe is not made of the stuff you know, and its behavior is revealed only indirectly, through how space-time bends and matter moves. That's not ignorance. That's precision without imagery. Once you accept that, a strange inversion happens. The question stops being, why don't we understand dark matter, and becomes, why did we ever expect understanding to feel intuitive? Your brain wants substance. The universe offers influence. Your instincts want stories. Physics offers constraints. Your imagination wants pictures. Reality offers curvature, motion, and statistics. And reality wins. This is the quiet brutality of cosmology. It doesn't shock you with explosions. It dismantles you with consistency. Observation after observation agreeing with each other, even when you don't like the implications. And here's the final reframing. Dark matter is not humbling because it's mysterious. It's humbling because it's normal. It is the default state of the universe. Non-luminous, non-interacting, gravitationally decisive. Atoms are the weird part. Chemistry is the weird part. Life is the weird part. You are the anomaly. The universe did not evolve to be seen. It evolved to obey its rules. You are a latecomer, trying to reverse engineer those rules from inside a structure built by forces you barely register. NASA isn't withholding that truth. They're publishing it relentlessly. The discomfort comes from realizing that understanding the universe doesn't mean making it familiar. It means accepting that familiarity was never the point. Dark matter doesn't care whether you picture it correctly. It only cares that galaxies move the way they do, space-time bends the way it must, and structure emerges on schedule. And every time you look up and feel certain you know what you're seeing, you don't. Not because knowledge is impossible, but because the universe is larger, colder, and far less interested in your intuition than you were ever told. That's the truth. Not comforting, not cinematic, just accurate. And accuracy is the only thing the cosmos has ever respected.